Brian for introduction. I'm Rendong Yang from China Agricultural University. The title of my presentation today is Circadian expression data by harmonic regression based on autoregressive spectral estimation. Generally speaking, I will provide an algorithm to deal with circadian expression data. And my is divided into two parts. In the first part, I will show you the biological background of our research. And in the second part, I will tell the detail of our proposed algorithm, which we named it as Arthur algorithm. And in the last part, I will do our results applying Arthur to the and the microarray data. Okay, first is the basic studied. Our study research of circadian rhythm. So what is circadian rhythm? It's about 24 hours, and it can be persistent. And usually we can describe this factors: period, phase, amplitude, and you can see from this graph the time of first peak expression. The amplitude is half the range of the period for the rhythm is usually within the 20 hours. Produced and by the circadian clock, the matching the machine clock. We can see in different species, they share mechanism of circadian relation. So, to figure out how matching the circadian clock, one is we have to address things are involved in this clock, and want to solve this problem. We will usually use the microarray data to monitor the expression patterns of and identify the genes with patterns. We will consider them as clock genes or clock controlled genes. The microarray circadian microarray experiment as the following. First, they will harvest the RNA samples every 4 hours during the 2 times, and we can say for each gene there will be about 12 time point series, and they will try to identify the from this series to see whether this gene is patterns or not. However, when we use statistical method to identify the periodic patterns, we will manage. Firstly, is the sparse determinant of this microarray experiment. With sample rate is not very high. It hours. So this is a very short time series. Will make many system analysis to lose their power, and also the macro high. And the third challenge is the replicate numbers of circadian rhythm experiments. Replicate at most one replicate number experiment. Considering the design of circadian rhythm experiment, several groups have proposed their own methods to identify the periodic patterns from such short-term series data sets. I will give you an example of the prior method to detect the periodic patterns for divided into two categories. One is the time domain. The other category is the frequency domain method. The methods are usually designed based on technicals. And for the based on Fourier transform. However, no matter the domain method or fraction or shortcoming of the time domain method, it first define cosine mode to fit the frequency domain method. However, for the they are low resolution time series. Limitations. We domain method to propose an algorithm to combine method. We propose a method which is named as Arthur algorithm, and I will show the basic principle of our method. First algorithm is used with a method called Autoregressive to do the frequency domain analysis to detect the period in a time series. If we have a time series, first we'll apply Autoregressive model for the E to fit this series by the so equation 1, we can get AI, and then we can estimate from our equation 2. They got in this time series by equation. After we'll continue to the time domain after determining and after we'll use a method called to do the rhythmic component modeling. The Harmonic regression model model rhythmic components by equation 3. This equation is very technical, and this and get the parameter of a circadian. The parameter means the level, and phi I is the phase. Equation 3 can be solved quickly in a linear form by equation 4. So this will give us a very quick computational time. Is the analyzing steps. First, time domain, and let's take our works to analyze the periodicity. We have generated the synthetic time series by this. First, we have a time series. First, processing step to remove the linear tree and do some noise filtering. After we'll do the frequency domain by AR autoregressive method to detect the period. If we don't include in the time series, there will appear a peak. Then with the period, the rhythm will work by using harmonic regression to fit the time series. The last other parameters, this period and the statistic p-value. how our method worked for time series. In our real application, we use algorithm to analyze large-scale temporal sets. So to analyze large-scale data sets, we will meet the multiple testing problems. We use false discovery rate to score the risk genes. And we also, in our study, we with two very widely used successful methods. One is called one belongs to the time domain method category. One is the Fisher test. This one belongs to the method. And we also three testing sets in our study. The first is generated synthetic data. The periodic series. The periodic time series. The stationary model. The stationary model includes with constant amplitude and mean level. The other one is simple. This one is the proportional damped amplitude and mean level. In our general data set contains the random series. All come from two models. One is the following standard random signals. The other one is such data are suggested by four patients. All the series in our testing data set are sampled during 2 days. Data set we prepare is public data set. In this data set contained 100 and also containing patterns you found in us. And the third is public set. The performance of algorithm. So I will show you our results. First is on our generated data. Generated 10,000 signal and 10,000 random signals. And then we signals and number we form 4 days. Use our algorithm are solved and the test from this to separate the periodic. So this we form it, and so it's very natural to use our frequency. The left figure is our the performance of 3H figure. The blue line other performance cases of the and we continue to not the to two factors is the noise in our generated periodic signals, and we also see it from the best in the next station invested the wavelength with the predicted wavelength and they are accurate. We find the answer is very prediction. And the second result is the 3 algorithm on period detection on the public synthetic data set. This set contains circadian rhythmic patterns. It identifies the most, especially for the spectral patterns. Now, the patterns. So, answer is also efficient at detecting non-sinusoidal patterns. And the last is our result on the public microarray data. We use the microarray data at our studying. Compare the 3 circles of the Fisher. In the original report, the paper used algorithm to apply Arabidopsis. The middle cycle is the largest cycle result of answer. We found rhythmic genes. And the result of originally reported genes are identified. Now we find answer identified about 7,500 genes. It's no genes, but with the computational validation. And the other is principal component to analyze the knowledge of we find the first 2 then we use about 27 clock and find 2 clock genes in this null site. The result may focus of or more further study of rhythm. So study of we propose combine time domain and frequency domain analysis for the analysis of the periodicity and tested simulation and superior to form after analyzing the Arabidopsis give us a null set of now to analyze even also algorithm for space samples. Construct and welcome biologists who study to use data for and you can find both section is for further questions. I will thank Professor John, Dr. Lee, Ms. Xu, and our colleagues in the lab. Our project is found of Science Technology of China, and I thank ISCB and ISF Fellowship Award and donation and
great talk. I just want to ask you that as we have seen the SR has a better rock curve, relatively better rock curve than other algorithms. Could you tell us that what was exactly the sensitivity and specificity? Because sometimes you might get a better rock curve but not very good sensitivity and specificity. So could you tell us that?
This graph?
Yeah, exactly.
Yeah, I can give the data, but I do not show the data. If you want to know the specificity the 98% from I have remembered.
Okay.
To show question that you in the method you first determine the parameters of the curve. Determine one period for the period for each gene. Same period maybe you do.
Sorry, miss. I to fit the terms and I got phases.
I understand that you one period one gene or for
No, for one.
Okay.
Okay.
And what? How will you periodic? But it's not a more complicated. It's it is
2 peaks is also okay. Details for to for the time of the presentation. Our algorithm uses the how you first detect the period. In this, we will find if 2 peaks or multiple peaks, the estimation in this equation, multiple peaks in the spectrum, all significant peaks at the period, the time series. And then we can model the components different, maybe different this time series by multiple ways.
okay. So you have
To 1 peak, 2 peaks, so multiple peaks also okay.
The question is, so you can detect the product, and how do you distinguish the cell cycle genes and the circadian genes?
Not in the algorithm, cell cycle or circadian genes determine cell cycle or rhythmic genes. For
in your studies, in all the gene sets that include cell cycle genes or excluded?
If the according to the design of Microarray data,
Okay.
In this range, we will treat it as circadian rhythm. In other range, we will treat it cell cycle genes.